Okay, let's move to the third type of a chemical bond. Okay, the first one is the ionic bond. Okay, refer to the video. Second is the metallic bond that we have discussed just now. Okay, so we have complete two type of a chemical bond in which we have three altogether. Okay, so this is the last one. Okay, I told you last time that this chapter is the longest chapter, right? Okay, but we have complete the first two. Okay, which is metallic and ionic. Ionic also short subtopic. Okay, and then if we calculate the percentage, okay, the two bonds, okay, metallic bond and ionic bond only covered about 10% of the total topic. Means that another 90% of this topic is actually come from the covalent bond. Okay, so we have much more on the covalent bond. Okay, don't be so happy when we have complete the first two. Okay, so let's say bond. Okay, it is actually the bond that is formed by sharing one or more pair of electron. Okay, when the atoms, the non-metal atoms are sharing at least one pair, okay, or two pairs, or maximum of three pairs of their valence electron. Okay, it is one or two or three pairs only of their valence electron. Okay, then they are forming covalent bond. But important that we have to know about this covalent bond, it is happened by the sharing of the electron. Okay, why the should share their electron? Why they have to share their electron? Why they don't transfer the electron? As what happened in the ionic bond. Okay, so they have to share their electron, okay, is to achieve a octet configuration. Okay, if you look at to the electrons in both of these two fluorine atom. Okay, this fluorine has 7 valence electron. Okay, fluorine group 17, you have to know that when it is come from group 17, it has 7 valence electron. Same goes with the second fluorine. It has 7 valence electron. Means that both of these two fluorine atom do not achieve octet. Okay, so in order for them to achieve octet, okay, they have to share their valence electron. So these two electrons are the electron that being shared. Okay, why they have to share their electron is to achieve a noble gas configuration or octet. Okay, why they have to achieve octet? Because octet is a stable configuration. Okay, so when they share the two electrons, so the two electrons shared, okay, is actually the formation of this covalent bond. Okay, so this shared electron represented by a single dash, okay, represented by this single dash that connect between the first and the second fluorine atom, okay, to show that they are forming a single bond with each other. Okay, so in the Lewis structure of the fluorine just now, there are two types of the electron pair. Okay, the first one is the bonding pair. Second is the lone pair. So what is the bonding pair? It is the electron pairs that involve in the covalent bond, that form covalent bond. Okay, as for the lone pair, they are the electron pair in the valence shell that are not involved in bonding. Okay, they do not involve in bonding. So let's look at back to the Lewis structure of the fluorine here. Okay, so we know that, okay, this is the actual one. We observe that, okay, the two electron here being shared between the two fluorine atom. And then this first fluorine, okay, has 1, 2, 3, 4, 5, 6 electron that do not involve in bonding. 6 electron means that 3 pairs of electron. Okay, so the 3 pairs of electron that do not involve in bonding in the first fluorine, we see that they are the lone pairs of the first fluorine. Okay, so the fluorine 1, okay, has 3 lone pairs. Okay, same goes with the fluorine 2. Okay, 1 lone pair, 2 lone pairs, 3 lone pairs around it. Okay, and then the electron pair that they shared, Okay, this electron pair that they share is what we call as the bonding pair. Okay, so if we refer back to this one, after we replace the shared electron with the single bond, so we see that the first fluorine has one bonding pair and 3 lone pairs. The second fluorine also has 3 lone pairs and 1 bonding pair. Okay, so if we have a structure of the HF, for example, HF. Okay, so how many electron pair around the hydrogen? So around the hydrogen, it has only 1 electron pair. Okay, so what is the type of the electron pair around the hydrogen? It is bonding pair. So hydrogen has 1 bonding pair. Now fluorine. How many electron pair around fluorine? Okay, fluorine has 4 electron pairs around it. Okay, 1, 2, 3, 4 pairs around it. Okay, what are the type of the electron pair around the fluorine? So fluorine has 1 bonding pair and 3 lone pairs. Okay, 3 lone pairs, 1, 2, 3. Okay, bonding pair is this. Okay, this bonding pair belongs to fluorine and also it is the same electron pair or the same bonding pair that is belongs to hydrogen because they are sharing the electron. Okay, it is the same as when I am sharing a car with my husband. Okay, we are sharing a car. Okay, if any person asks me how many car that I have, the answer will be 1 car. If that person asks my husband how many car that you have, the answer will be 1. Okay, we'll never reply by half. Or I have half car, my husband has half car. Okay, because we are sharing the car, right? Okay, so don't get confused on why both of them are having 1 bonding pair. Okay, not just half of the bonding pair. Okay, because they are sharing the electron. Okay, so covalent bond is divided to 2. Okay, the ordinary one. Okay, and also the covalent coordinate, or it is also known as the dative bond. Okay, so what is the difference between the ordinary covalent bond and also the covalent coordinate bond or the dative bond? You have to remember these two terms. Okay, they are the same. Coordinate covalent and dative, they are the same. Okay, so in the ordinary covalent bond, okay, 1 electron is shared from each atom. Okay, means that if let's say we want to form, if let's say we observe the bond that is formed between the 2 atoms in hydrogen in H2. Okay, they are forming hydrogen bond. The first H provide 1 electron. The second hydrogen also has 1 valence electron. Okay, in which these 2 valence electron is then being shared. Okay, and they are forming 1 covalent bond between them. Okay, 1 atom provide 1 of the shared electron. It is the same as the fluorine case just now. Okay, each fluorine will provide 1 electron to be shared with the second fluorine. Okay, so that 1 and 1 electron then being shared, and then they will form S2, single bond between them. Okay, and that is for the ordinary covalent bond. What if the dative bond? What is the covalent coordinate bond? Okay, it means that only 1 atom that provide both of the shared electron, only 1 side, okay, that provide both of the electron to be shared. Okay, they are still sharing their electron, but only 1 atom that provide the electron, the 2 electron being shared. Okay, so let's look at to the example of the compound, okay, that form this covalent coordinate bond or the dative bond. Okay, is in the formation of the hydroxonium ion. Okay, so if we look at to this hydroxonium ion, okay, H3O plus, Okay, this is the structure of the H3O plus. Okay, it is actually formed when we have a H2O react with the H plus. Okay, H2O with the H plus. So when they are reacted, okay, means that they are forming a chemical bond. So we know that hydrogen has only one valence electron. When it turns to H plus, means that it has no electron at all. Okay, it has one electron initially as atom. Turns to H plus means that lost one electron. Means that hydrogen has no electron to be shared with the oxygen. So what happens is the oxygen will provide two electrons or one lone pair to be shared with the hydrogen to form the dative bond. Okay, but they are still sharing the electrons. That is why it is still under covalent bond. It is not the oxygen transfer the electron. Okay, the oxygen provide the two electron to be shared. Okay, another example. Okay, in the formation of the ammonium ion. Okay, ammonium is a NH4 plus. Okay, it is formed by the reaction between ammonia and also H plus. So you have to be able to choose the formation of this dative bond. Okay, by drawing the Lewis structure of the ammonia. Ammonia has 3 hydrogen attached to it and 1 lone pair. React with the H plus. Okay, the same as this H plus when it has no electron at all. So that what happen is the ammonia will provide these 2 electron to be shared with the hydrogen. Okay, so that it will form and with 3 hydrogen. This is the initial one and then the 4th hydrogen. Okay, and since that we are learning dative bond, okay, we are learning dative bond, then we have to show that which one that is the dative bond. Okay, and this is the dative bond. We have to label it. Okay, and another one thing is we have to have the arrow head. Okay, the same bond, but the difference is just we have the arrowhead towards the one that receive the electron, from the one that provide to the one that receive it. Okay, since that nitrogen is the one that provide the 2 electron to be shared, so that the arrow head towards hydrogen. The length of the bond are the same as the other 3 bonds. Okay, it is just it has the arrow head towards the one that receive it. Okay, then you don't forget that this is the polyatomic ion. They are ions, so that you have to put them in bracket with the positive charge. Okay, so the ion must be in bracket, okay, with the charge outside. Okay, another example of the compound that form this dative bond is the bond that is made between the reaction of the BF3 and NH3. Okay, so when the BF3 and NH3 reacted, so they will form a BF3 NH3. Okay, let's look at how the bond is formed between them. Okay, BF3 has 3 terminal fluorine. Okay, and then it is reacted with the ammonia with 3 terminal hydrogen. And nitrogen as the central atom has 1 lone pair. Okay, boron central atom has no lone pair. Okay, when they are forming BF3 and H3, the bond is actually made between nitrogen and boron. Okay, the bond is made between nitrogen and boron. If the bond is made between nitrogen and boron, if in the ordinary covalent bond, each atom need to have at least 1 electron to be shared, right? However, okay, boron has no electron left. Okay, it has only 3 bonding pair. It has no lone electron. It has no lone pair. As for the nitrogen, since that it has one lone pair, so the nitrogen will provide these two electrons to be shared with the boron. Okay, so this is what we call as the formation of the dative bond between them. Okay, we have B, F3, okay, bond with the nitrogen with 3 hydrogen. Okay, and then remember we are discussing about the dative bond, so we have to show which one is the dative bond, and it is by arrowhead, and it is towards the one that receive the electron. Okay, so since that nitrogen is the one that provide, boron is the one that is received, so the arrowhead towards boron. Okay, this is a neutral molecule, so we don't need to have a bracket. Okay, but still you have to label it. So this is the dative bond. Okay, this is how you show the formation of the dative bond. Okay, it is different with the ionic bond, in which the ionic bond you have to have the arrow. Okay, from the one that is donate to the one that is receive it. Okay. This is what I said just now. So boron does not have a full outer shell. Okay, boron does not have a full outer shell. If you look at to the structure of the boron, it has only 3 pairs of electron around it. It is not octet yet. Okay, so it is able to accept electron pair from the ammonia for it to achieve octet. Okay, so now after it receives the electron pair from ammonia, now this boron has 1, 2, 3, 4 pairs of electron around it and achieve octet configuration. Same goes with the nitrogen. Okay, so if you look at to the nitrogen, now it has 1, 2, 3, 4 pairs of electron, the same as before. Okay, before the bond is formed, nitrogen also has 1, 2, 3, 4 pairs of electron around it. The difference is just, okay, before the ammonia form a bond with the BF3, it has 1 lone pair, 3 bonding pairs. After it form a bond, all 4 electron pairs are bonding pairs. Okay, that is on the dative bond.